So here we have maybe my favorite week of the course, the machine learning week, with thanks to Tony, Alana, and Kavani. Let's briefly talk about machine learning. Machine learning is becoming super popular. Here you can see over the interval from 1992 to 2016 how the number of occurrences are very rapidly growing up. And when I say number of occurrences, it's the number of papers per year that mention the wording machine learning as part of the content. And you can see that the number of patents pretty much tracks the number of publications. Now, machine learning, when I say this, it's a broad umbrella for many things. But specifically, we'll be talking about supervised machine learning. We have a matrix, let's call it X, where we have for a bunch of samples the associated features. And we have a label, vector, which we might call Y. It goes through training. The training gives us a model. Now, the model has the ability to accept additional samples, an additional feature matrix, samples by features, and make predictions. Now, which problems is machine learning solving for us? There's arguably a bunch of completely different applications for it. For example, it's solving engineering problems for us. We have brain data. We want to know what the brain data means. For that, we have labels. So in this case, they produced a data set of labels, which is what does she want to do? They have features, which is the activity of each of the neurons. And they basically are now able to predict what she wants to do without asking her what she wants to do. In this specific case, they can use it for an engineering application, which is allow her to feed herself using the robot. Now, we also use it to understand data, where we can use machine learning to ask what one set of data elements have in common with another set of data elements by phrasing this as a prediction problem. What do we know about that other data set given the data from the first? Machine learning can be a benchmark. Maybe us wearing a scientist hat want to have a model. We want to have a model that we believe is good. But what does it mean for it to be good? Just a model being better than another model doesn't make it true. Now, machine learning often is a very generic model that we can compare models against. If you want, machine learning can be seen as a yardstick in this context. Lastly, and specifically important for the field in which I am, machine learning can be viewed as a model for the brain. The brain is solving a learning task. Machine learning is solving a learning task. In that sense, things that we find out about learning are probably true about both. That's the background. So there's lots of different reasons for why we want to be good at machine learning. And today, we'll learn the techniques that we use for that.